Good day everyone. Today we will discuss the introduction to fluid mechanics for science education teachers. If you're looking for fluid mechanics for engineering, this is not the lecture series for that subject. Before we define fluid mechanics, let's start first with fluids. What is fluid? You may answer liquid or water as an example. You get the idea, but it is not complete. Fluids are liquids and gases that have the ability to flow. What describes fluids is the word flow. Since fluid composed of gas and liquid, so what is the difference between liquid and gas as fluid? A gas is a fluid that is easily compressed, while liquid is a fluid which is hard to compress. Another difference between liquid and gas is that in a liquid, groups of molecules can move relative to each other, but the volume remains relatively constant because of the strong cohesive forces between the molecules. As a result, a liquid takes the shape of the container it is in, and it forms a free surface in a larger container in a gravitational field. A gas expands until it encounters the walls of the container and fills the entire available space. This is because the gas molecules are widely spaced, and the cohesive forces between them are very small. Unlike liquids, a gas in an open container cannot form a free surface. After we define fluids, we can now define mechanics. So, what is mechanics? Mechanics is the oldest physical science that deals with both stationary and moving bodies under the influence of forces. Remember the word stationary and moving bodies. Under mechanics, we have two branches, namely, statics and dynamics. Statics is the branch of mechanics that deals with bodies at rest. On the other hand, dynamic is the branch that deals with bodies in motion. Now, we are ready to define fluid mechanics. So, what really is fluid mechanics? Fluid mechanics is the science that deals with the behavior of fluids at rest, fluid statics, or in motion, fluid dynamics, and the interaction of fluids with solids or other fluids at the boundaries. There are other disciplines and categories related to fluid mechanics. One of these is hydrodynamics, which is the study of the motion of fluids that can be approximated as incompressible, such as liquids, especially water, and gases at low speeds. A subcategory of hydrodynamics is hydraulics, which deals with liquid flows in pipes and open channels. Gas dynamics deals with the flow of fluids that undergo significant density changes, such as the flow of gases through nozzles at high speeds. Aerodynamics deals with the flow of gases, especially air, over bodies such as aircraft, rockets, and automobiles at high or low speeds. Other disciplines like meteorology, oceanography, and hydrology, which deal with naturally occurring flows. One of the characteristics of fluid is it deforms continuously when acted on by a shearing stress of any magnitude. What is shearing stress? A shearing stress, force per unit area, is created whenever a tangential force acts on a surface. Example of this is when you paddle into the water. Let's proceed to dimensions, dimensional homogeneity, and units. What is dimensions? Any physical quantity can be characterized by dimensions. For example, length, time, mass, temperature, electric current, amount of light and amount of matter. On the other hand, the magnitudes assigned to the dimensions are called units. Example of units are meter, kilogram, second, Kelvin, ampere, candela, mole and many more. Dimensions can be categorized if it is primary and secondary. Some basic dimensions such as mass m, length l, time t, and temperature T are selected as primary or fundamental dimensions, while others such as velocity v, energy E, and volume v are expressed in terms of the primary dimensions and are called secondary dimensions, or derived dimensions. The symbol dot equals, which refers to as defined as, is used to indicate the dimensions of the secondary quantity in terms of primary quantity. To describe velocity, v dot equals lt to the -1 or meter per second. All equations are required to be dimensionally homogeneous. The dimensions of the left side of the equation must be the same as those on the right side, and all additive separate terms must have the same dimensions. The MLT and FLT systems are used to describe the dimensions of common physical quantities. Take time to familiar with the units of these dimensions. There are three known systems of units: the International System, British Gravitational System and English Engineering System. In SI the unit of length is the meter, m. The time unit is the second, s. The mass unit is the kilogram, kg, and the temperature unit is the Kelvin, K. In the BG system the unit of length is the foot, ft. The time unit is the second, s. The force unit is the pound, lb, and the temperature unit is the degree Fahrenheit, or the absolute temperature unit is the degree Rankine. In the EE system, units for force and mass are defined independently. Thus special care must be exercised when using this system in conjunction with Newton's second law. The basic unit of mass is the pound mass, lbm, and the unit of force is the pound, lb. The unit of length is the foot, ft, the unit of time is the second, s, and the absolute temperature scale is the degree Rankine. Be familiar with prefixes since we will be using them in the rest of the lessons. This is the end of our first topic. The problem solving for this will follow. Hit subscribe and hit the bell button so that you will be updated whenever a new video will come out for our next topic.